Hi, very good evening. Assalamualaikum. It's not too afternoon. It's evening already. So, upon request, last time I already upload this video for this chapter 2, part 1, but unfortunately, I uploading a video with no sound. Sorry, because I'm too nervous. So now I'm recording back. I'm at home now. We working at home. You cannot go outside because of pandemic. So the part 1 of the chapter 2, we study about the oscillator. For the last lecture, I already explained something about the oscillator. So this is the early part of the oscillator. Actually, because before we jump to the chapter 2, part 2, we need to understand the part 1 first. This is the part 1. Okay, you can see here, oscillator is an electronic device. It used to generate a signal carrier, which is in the form of wave and also the frequency. And every time we're talking about the wave, every time we're talking about the carrier and the signal and everything, we always talking about the frequency. We're talking about the wave. So the oscillator is an equipment to produce a carrier. Why we use the carrier? The carrier is very important for the data transmission. Data is like a people. Carrier is like a car. When we want to travel from one point to another point, for example, from here to UTM, we need to using a car. We are the data. The car is the carrier. So the oscillator is used to build a car or to build a carrier. Okay, that's simple. So the oscillator, it cannot working by itself. It need a power supply. Okay, this is the power supply, and then this is oscillator, and then this is the output. So the output in the waveform, it can be like this, or triangular, or rectangular, or triangular, or sinusoidal wave, as long as the carrier must be larger than the data. So the car must be bigger than the people. So that's reason, because of people can get into the carrier and transmit. The same thing happened with the data. Okay, that's the introduction. So here there is 3 types of oscillator normally used in communication. The first is Hartley, second is Colpit, and the third is clap. The same function to produce a carrier, but the structure of the circuit is slightly different. Okay, three normal oscillator we use, and there is 4 criteria. When we use the oscillator, we want to determine whether this oscillator is very good or not based on these 4 criteria. The first is input, gain, frequency, and feedback. The input first. Input is a power source, so the power should be suitable with the oscillator. Second is gain. How big the signal can be expand to be a very huge oscillator, very huge carrier. And the third is frequency. Of course, when we want to create a carrier using oscillator, is That means we create a frequency, a wave, and finally a feedback. Everything we create, we need to know how good it was, depend on the feedback. Okay, this is the simple block diagram about the oscillator. The first is oscillator, create a carrier, and the second is modulator, combine the carrier and the data. Combine, modulate. We call it modulate or combine between carrier and also the data. And then the third is amplify. When the process, the combination process, it will cause a lot of losses. That's why we need the amplifier to boost the power before we transmit. And then during the receiver part, this is the transmitter part and this is the receiver part. At the receiver part, the signal get into the receiver antenna and then amplify first, because during the data transmission there is a lot of losses because of the wind, because of the building, because of the tree, because of the weather. That's because when the signal get into the receiver, we need to amplify to increase the power. Before we demodulator, we separate between a carrier, between the where is my hand? Okay, what is this man? Between the carrier and also the data, we have to separate. Okay, that is demodulator. And then amplify back, and detector finally going to computer or anything of detector of output. Okay, this is the LC oscillator. When we talk the oscillator, we already know that this oscillator is equipment to generate the carrier signal to carry a data. But the main component in the oscillator is L and C, which is inductor and also the capacitor. This is the first types of oscillator. We call this as Hartley oscillator. The difference between Hartley oscillator and other type of oscillator is the number of capacitor and the number of resistor. Capacitor and also the inductor. sorry. So the Hartley oscillator got 2 inductor and 1 capacitor. So the inductor will be put as a series parallel with the capacitor. That's the Hartley oscillator. So what we need to know from this oscillator, the first is power. This is the power. Okay, and then we need to know the frequency. This is the frequency. LQ equal to L1A plus L1B plus 2LM, and LM is here, and K is I forgot in English, but in Malay we call this pemala. So every time we want to calculate the function, the quality of the oscillator, they will give the K. The frequency and also the feedback and also the gain, how good is the based on the feedback, how good is the oscillator, and then the gain, how great is the oscillator to create, how big the signal it will create. Okay, this is the example, and then so this is also the example, and then this is the calculation. Nothing, because it's not too difficult. The second oscillator, the second type of oscillator is a Colpite oscillator. The same things, playing with the capacitor and also the inductor. So here there is 1 inductor, 2 capacitor. Compared to the Hartley, 2 inductor, 1 capacitor. The same things. playing with the capacitor and also the inductor. Okay, so from here we need to know the power. This is the power, and then we need to know the frequency. This is the frequency, the feedback, and also the average gain. Okay, when we see about the feedback, how good is the oscillator based on the capacitor 1 and capacitor 2. Okay, and how big the carrier is depend on the capacitor 1 and 2. Okay, what I try to explain here is when we see the gain, when we want to know how big is the carrier, we see the gain. So from this equation, we already can, we always can understand the average, the gain is totally depend on the sorry, just having a lunch, so my English not so good. So the gain is totally depend on the C1. When the C1 is smaller, the gain is bigger. When the gain is bigger, the C2 also bigger compared to the Hartley. Where is the Hartley? Hartley oscillator. The factor, the feedback depend on inductor, and the gain is depend on inductor, not the capacitor. But the Colpit, the gain depend on the capacitor, and the feedback depend on the capacitor. Okay, this is the example. Some more example also. Okay, this is the clap oscillator. For the clap oscillator, is the combination between capacitor and also the inductor. Here, we can see here, there is 3 capacitor and 1 inductor. This is the clap oscillator. Okay, during the clap oscillator, there is 2 type of stability. The first is short-term stability, and second is long-term stability. For the short-term stability in the DC on, okay, nothing important. Okay, that's all. So the first part of this chapter is we study about the oscillator. What is oscillator? Oscillator is the equipment to generate the carrier, because the carrier will use to carry a data. So there is 3 type of oscillator: Hartley, Colpit, and clap. Which one is better depends on the calculation, depend on the power, depend on the gain, frequency, and also the feedback. Okay, but most of the time we see the gain and also we see the frequency. How big is the frequency? How good is the gain of the frequency? Because every time we want to create a carrier, we need to create a big carrier, a huge wavelength, a huge frequency, because we want to put everything, the data before we carry. Because during the transmission, there is a lot of losses, yeah, because of the losses, because of the component, the losses because of the heat, because of the weather, because of the everything. So that's because we need to create a very big and very huge, very strong carrier. And to create a very strong carrier, we need a very good oscillator. So how good is the oscillator depends on these 3 things. It doesn't mean Hartley is better than Colpit is better than clapdown. Either one, it's not either one. All of this oscillator is good, depends on the function. Okay, that's all. So we continue with the chapter 2 part 3.